Hello everybody, welcome back to Planet X News, June 29th, 2021. Well folks, I guess a lot of you have already heard about the historic heat wave that is stretched across the entire United States just about. And I'm sure that some of you are experiencing this heat wave. I've been charting this and watching it very, very closely over the last couple of days. And, naturally the meteorologists and the weathermen and scientists, they're kind of blaming it on this dome of high pressure that is formed over the United States. However, this dome that they're talking about over just the United States, well, I don't know about that, folks. If you check out the weather forecasts over in Europe and other parts of the Earth, north of the equator, in the northern hemisphere, we are being blasted by very, very high temperatures. And yes, I do understand, and I do recognize that it is summertime, and we're heading into just about the middle of summer. So we could expect some high temperatures. And that's normal. But whenever we start to talk about record-breaking heat, smashing records in areas of the United States that normally do not see temperatures anywhere near what we're going to discuss. I've mentioned many, many times in the past that I feel, and from what some of this data shows with the Earth wobble, which takes 365 days for the Earth to complete this wobble on its axis. If the Earth's wobble continues to become more drastic and more prominent, well, that means that little by little, as the Earth's wobble becomes worse, then that means that different areas, different sections of our globe are going to be exposed to drastic temperature changes. Now, that would mean drastic heat temperatures in the summer in the northern hemisphere and drastic cold temperatures in the southern hemisphere. If you guys don't believe me, just go look and see what the weather situation is down under in Australia and specifically over in New Zealand. I was reading some crazy weather forecasts for New Zealand, and it's very, very cold. But getting back to this historic heat, here in the United States, it is definitely putting a stress on the electrical grids, and that's something that we always worry about. I was talking to a friend of mine that lives in Northern California, and they were worried about these, what they call like a rolling brownout, where they cut out the electricity because they're trying to save power. So, you basically end up with no lights, no air conditioning, no nothing. Now, when I lived in Miami, Florida, we did have those same rolling brownouts. They occurred in the middle of the night, and they shut the electricity off in a grid pattern. And, maybe it's for 2 or 3 minutes. They feel that it saves electricity and it de-stresses the electrical grids. But when you are talking about temperatures that are exceeding 100 degrees, well, these rolling brownouts just, frankly, suck. And if you're putting so much stress on these electrical grids and you have major power outages, well, that situation just got worse. Because now you're going to be without power power for a prolonged period of time, with temperatures soaring above 100, 105, 110, 115, and temperatures seeing as high as 117 degrees. That's like being in Death Valley. But no, these are temperatures being recorded in Pacific Northwest states such as Washington and Oregon. So, there's a lot of headlines all over the media. Matter of fact, let me just jump out of here 1 second and we'll go ahead and check this out real quick. If you just look at the headlines, Pacific Northwest bakes in record-setting heat wave. If you guys want to review any of these articles, just go up to Google or whatever browser you use, type in heat wave, as you see right here. Go to news, and you'll start to see all of the articles. Now, even Canada, Canada's weather is, not too bad in the summertime. Comfortable. Well, they're a victim of this heat wave also. The crap news network, CNN, the Northwest heat wave is unprecedented. Here's what's pushing it into uncharted territory. Amazon opens cooling centers in Seattle headquarters amid record-breaking heat wave. Pacific Northwest is one of the most intense heat waves ever, with the worst still to come. The articles just keep going on and on and on. Now, this is referring to a lot of these articles, what is going on out on the West Coast. It seems just over the last couple of days, as temperatures start to rise in the central part of the United States and over to the East Coast, where we get more humidity. Now, yesterday, let me step back. We've been having a pretty, I'd say, mild summer so far here on the East Coast. All of a sudden, boom, we start hitting temperatures in the high 90s. And you all know, if you live east of the Mississippi, we get that heavy humidity. Well, yesterday I went outside at about noon, and it was well past 90 degrees, but the humidity level was so high, I couldn't breathe. I went to, take a early afternoon walk just for some exercise. And I'll tell you, I got about 15 minutes into that walk, and I was drenched, and it was very, very hard to breathe. The air was so thick. But if you guys want to, check out some of these articles, I'm sure within the next few hours or the next day or so, these articles are going to be updating, and they're going to be talking about what's happening on the East Coast of the United States. Also, we're getting into close to the beginning of July. Very high possibility that things are going to start to heat up in the Atlantic with our hurricane season. There's already a nice-sized tropical depression coming close to the east coast of the United States. We'll be keeping an eye on that. And, folks, this is something that I've talked about for a long time. And, again, I'm going to repeat myself from previous videos. As we get further and further into this solar maximum, this is where we're going to start to see things change drastically. I'm just going to go ahead and pull up some of our views of the sun, because there's a lot of activity going on the sun, as we speak. A lot of coronal mass ejections, a lot of sunspots forming. And there have been several coronal mass ejections over the course of the last couple of days. Pretty big ones. One of them, that was on the 27th, revealed some very nice shots of this Planet X stellar core object. I was quite amazed. I'm going to share those photographs with you. Within those photographs, once again, we've detected some smaller bodies, and I'll get into all of that with you in just a few. But we can take a look at what's going on the sun now in this composite view from the Solar Dynamics Observatory. You can see a very, very, very large active region here. 3 here, 1 here, 1 here, and kind of nothing going on along the equatorial region or the equator or the middle part of the sun right here. As I have mentioned before in my previous videos, I've been watching this formation of these active regions for a very, very long time, going all the way back to 2016, where we see all of these active regions forming above and below the sun's equator, northern and southern hemisphere. And we are now, we were supposed to be traveling very slowly out of this solar minimum and into a solar maximum. But as I've mentioned, it seems for some reason, which I call the X factor, the planet X factor, this acceleration into the solar maximum is just that. It is accelerating at such a fast pace. It's absolutely incredible. So basically, we're going from a sun that was partially dormant during a solar minimum, because over these past 5 years, we've seen nothing but activity, coronal mass ejections, consistently during a period of just a week, a month. So now, all of a sudden, as the sun is waking up, it seems that it's being pushed just a little bit more to wake up even faster and move directly into this solar maximum. Well, what does that mean? Well, that means greater chances of larger coronal mass ejections, more direct radiation coming from the sun impacting the Earth, therefore heating up the Earth's atmosphere. So, what exactly created that huge dome of heat that they're talking about? What, it just formed all by itself? What is it, just a weather anomaly? Well, obviously, the atmosphere had to be heated drastically and rather quickly for something like that to form. And to smash records in a Pacific Northwest state such as Washington, to reach temperatures of 117 degrees. You tell me, did the weatherman get it wrong? Probably. Sometimes they do. But they don't normally, take a look at the sun. They just pay attention to the weather. But maybe for once, if they start to expand their science a little bit, maybe they would see what is happening. And if things continue in this pattern, we are going to continue to see record-breaking heat, the atmosphere heating up. And with the heating up of the atmosphere, well, you have the great potential of massive storms. Massive storms. Now, just last week, I live in the Pittsburgh area on the East Coast in Pennsylvania. We had some downpours last week that were absolutely incredible. there were areas such as Morgantown, West Virginia, where WVU University is. Wow! They were like underwater. Massive downpours. There were some tornadoes that blasted through Tornado Alley last week and over the weekend. But this is what is coming, folks. I believe, my hypothesis is, okay, we have another object out there that does have a very strong magnetic field, and it's kind of like a tug of war between that object and the sun. And as the sun is waking up and moving into this solar maximum, well, when the sun wakes up, and now all of a sudden we have this bumping of heads between the magnetic field of this Planet X object, or whatever the hell is orbiting our sun and that I've been capturing and showing all of you for years. This tug of war between that object and the sun as the sun wakes up. Wow. What are we going to be looking at in the days, the months, and the years to come? Because, as you all know, a solar cycle is 11 years. So we're just now moving into this solar cycle 25, a solar maximum. And usually the first 5 years of a solar cycle is the most intense. You getting my drift? So the possibilities of us just seeing the infancy, just the tip of the beginning of what is to come, to me, is a little scary. And the sun is booming with activity, as you can see. We'll go ahead and we'll jump over to the 211. Once again, you have a nice big area up here. But this area here, these coronal holes up here, these dark areas, splitting right down through here. But this area, very active region. Here, 1, 2, 3. And we can see all of these if we just dip down. Let me just go down here a little bit. And we could see all of these active regions, all of these sunspots right here, right here, right here. And you notice that they're northern hemisphere, southern hemisphere, but very close to the equatorial region. Why do I point that out? Well, that's about where we are located as far as the Earth. So you have the equatorial region right here. The Earth's position is just a little bit below that. So any explosion directly from these sunspots or active regions would impact us, and the same applies here. So we are kind of just a little bit towards the lower middle of the sun as far as the Earth's position facing the sun. So, we're kind of close to the bullseye range. And any massive coronal mass ejection, well, it's going to impact the Earth. The biggest problem would be direct hits to our electrical grid, especially in the time where you need air conditioning, because the temperatures are above 100 degrees plus. I couldn't even imagine 117 degrees, 110, 115. Me, personally, I've never been anywhere where I've experienced that type of temperature. To walk out of your house and, go stand in your driveway and experience 117 degrees of heat outside. God forbid anybody working out there, for 8 hours a day. So, precautions. So we will see. We have so much time ahead of us before we even get into the more intense stages of what you're looking at. What you're seeing on your screen now with these active regions, folks, let me tell you something. I've seen the sun in the previous solar cycle, and it was just absolutely crazy. The last solar maximum I'm referring to just lit up like a sparkler on the 4th of July. So with the intensities of the coronal mass ejections, the intensity of the radiation, the intensity of the heat here on Earth, beginning, in the beginning stages of this solar maximum, we are already seeing temperatures close to 120 degrees. And we're in the beginning stages. My point is, how much more will we be able to take? God forbid that any forest fires start to erupt out west here in the United States. Because that will be catastrophic. It will be so intense. And as far as the firefighters go that battle these forest fires, if they are battling these fires along with the heat of the fire and intense heat, such as 110, 115, 117 degrees on top of what they're experiencing in the forest fire, the damage, we've all seen the damage that's been done over the last couple of years. I yelled at my neighbor yesterday when I went outside. I smelled something burning, like, wood, somebody burning, like, garbage, whatever. And, he has a 55-gallon barrel, and he burns newspapers or whatever. Even though we had all that intense rain last week, everything dried out very, very rapidly. My grass has already stopped growing. It's already turning yellow, just like everybody else's. Trees are already starting to wilt. Plants are starting to wilt in the intense sunlight. And this guy's back there, and he's got his burn barrel going with all kind of hot sparks floating up into the air. And I went over and I said, hey, listen there, mister. It's not a very wise idea to be, burning your newspapers. They're floating up into the air, and everything around us is dry. Not everybody has common sense. We all know that. But that's what it's looking like, folks. That is what it's looking like. I'm going to jump over here real quick. Get out of here. And we can take a look at the windy.com. Real good way to, check out weather and things of that nature. Windy.com. You guys can see it right up here. Pretty interactive. You could use a flat screen, or you could use the 3D model that they have up on here. If you're not familiar with how to use this website, pull it up, check it out, spend about a half an hour, and you'll figure it out. But what I was doing is I was zooming in to this area, And there you go, 117 degrees Fahrenheit. And that was just over the border into Washington. Washington, 117 degrees. I'm talking about the state of Washington. That's insane. And the temperatures, if you click into an area just like I did there, it will give you the temperature, 109. Let's go down in here in Northern California, 105. Let's dip down over in this region where you see the darker colors, 106, 108, 107, 98. Let's get along the Mexican border, 104. So you can see, yeah, that dome of high pressure is just off here. But this low pressure, they have it listed right now as a low pressure. But the other models that I was looking at yesterday had it set as a high pressure that had formed. So if you want to play it out, you could hit the little arrow button over here, the little play button, and it will go through a time scale Wednesday. It will give you kind of a predictor model, and you could stop it, you could go back, you can slide it all the way back, and you could see how this heat starts to erupt as it moves along. Intense. And you could back out. You could spin the Earth. Naturally, the temperature is going to be quite high in northern Africa. And remember, there's a time zone difference. So if you let that slide, you'll be able to see these. I'll go ahead and move it back here. You'll be able to see the temperature changes as the time scale moves along. Ooh, just gets darker and darker. Let's see what this temperature is in Iraq. 122 degrees. 116. 109. 107. 102. 107. Northern India, 108. 107. 115. Europe's not looking too bad. 93, southern Italy. 96, Serbia. 99 degrees. Southern Spain, 90, not too bad. 109, 105, 102, 107. You know, folks, these areas up here, they don't normally have temperatures anywhere near what we're looking at. $116, 110. Intense. Very intense. And then you get down here to little New Zealand. 24 degrees Fahrenheit. 28. North Island. 43. So, you know, as I was saying, very, very cold in New Zealand. And record breaking. Something that was very interesting that I was looking at, and I'm just going to spin us back around here to the United States. And as we look, let's see if we could get a temperature reading directly at the top of the axis of the Earth in the North Pole, the Arctic. 33 degrees. That's it. Let me spin this around again. Lost my track here. So naturally, you know, Greenland with the high elevations, 12 degrees Fahrenheit. But let's take a look at this little region right here. This little swath of open area. pretty close to the North Pole, 40 degrees. Something that has been occurring is this airflow, this hot air. Over the last several years, this has been occurring nonstop. These air currents move straight up into the Arctic. Iceland, just the name tells you it's cold. Let's see, here's pretty close to one of the northern tiers. 64 degrees, Iceland. 64. So that warm air is passing right over Iceland, and it's moving directly into the North Pole. You can see areas here, 35 degrees, back up a little bit, 43 degrees, 41 degrees. Move into freaking Siberia. 92, get out of here, 92 degrees. 73, 67. Northern Finland. Read an article about northern Finland and their temperatures last week. Pretty warm. Let's go all the way up in here to Norway, Sweden, and Finland, and let's just click and see a temperature. 49 degrees. 47. Southern Finland. 75. Southern Sweden. 64, not too bad. 64 in Norway. Now, I'm sure a lot of these temperatures are going to, once again, change. And they're going to be seeing very, very high temperatures in these countries. Just amazing at how hot the Earth is getting. 122 degrees there. 118. Now, with these very, very high temperatures that you see here in northern Africa, well, this is where the storm systems roll off of, just about between here, and they roll off, and then that's when you see those hurricane systems, tropical depressions, start to form, and then what happens? They grow in intensity, and they make their way, to the United States, and then they do some damage. So if you guys want to check out windy.com and maybe save it, bookmark it on your browser, you may need it if you live anywhere that's experiencing some crazy wild weather. Pretty good tool to have. Now I want to go ahead and jump into we already saw this. You can see on this one scale of the Earth of the United States, North America, you could see the intensity of the heat. And yeah, you would think that the red area would be the most intense. But the way this scale was set up, you could see these areas in pink and in white are even more intense as far as the heat goes. This was from NOAA, Northwestern U.S. Preliminary Temperature Records. This was from Sunday, June 27th, 2021. Washington, 115 degrees, 109, 105, 104, 102. These were cities and towns that recorded record-breaking temperatures in the state of Washington. The state of Oregon, 113, 112, 112, 111, 101. The state of Oregon. Here was something I found quite interesting. California, Northern California, 103 degrees Fahrenheit at Mount Shasta. It breaks a previous record by 5 degrees, which was held in 2015. Incredible. Absolutely incredible. These are more all-time record high temperatures. This was from the 27th also, 2021. Lists the towns that broke records. Pretty intense. Pretty intense. So, we're going to be seeing more and more and more of this as time goes on. And I think the summertime this summer is going to be pretty interesting. Let's move into some of these photographs that I've snatched. Let me get over here a little bit. Okay, so getting into the Planet X photographs from the 27th. Very, very interesting. A lot of coronal mass ejections. I've been keeping track of them each and every day. Did have a problem with the server that I connect with to upload all of this data to do my research, and for about a week, I don't know what happened, but we lost contact with that server, and kind of put Planet X News at a standstill for a bit. But I went through all the data once I was able to get it all uploaded, and it took days and days. And the only thing that we were able to capture was this remarkable photograph from the 27th. This was due right at the point of a pretty large coronal mass ejection. You can see it right there before your eyes. We'll go ahead and take a closer look at it. Perfect. Absolutely perfect. So we can see this object. It is off the eastern limb of the sun. So the way we're looking at it, the directional way, left would be the east, and right would be the western limb of the sun, the way that we're looking at it now. We could zoom in even further, and these little X's, these appear. This is showing you the intensity and direction of the coronal mass ejection. Pretty cool photograph. Pretty damn clear. I'm also going to show you some other things that appeared in these other photographs. We have the negative version of what I just showed you. You can clearly see it right here. So this was a coronal mass ejection, and there was one on this side and one on this side. Notice the difference in shape. This one is more square or rectangular shaped. This one has the nice big teardrop shape. Why? Because it is enveloping a massive spherical body that has got caught up inside of it and that created it. Let's move to another close-up. Very, very clear images this time around, folks. Very, very clear. Just intense. That's as close as we're going to get. And as you can see, it's not pixelated, slightly blurry, but that's due to the quality of the data that NASA gives us. This is the LASCO C2. This is in kind of like an X-ray type of view. And this is where things started to get interesting. So, once again, we can see this object right here. And I'm going to just jump right over. And we start to see these other smaller little specks. This object up here, which I will show you, and these little white objects, just these little white specks, they become very interesting as we progress into these photos. See, there's that object right up there. I didn't pay too close attention to this or this or this. until we got more data back and the other photos came back, and then it got me going as far as, okay, what are we looking at here? So as we take a view, as you see on your screen now, so folks have made comments, oh, it's a space bubble. Okay, well, I don't know about you folks, but, whenever you were a kid and, your mom or your dad gave you some dish soap or, the little bubbles in the bottle and you blew bubbles. Well, how long does a bubble stay perfectly spherical? Never is the answer. Never. So for folks commenting and saying, oh, that's just a space bubble, it's a plasma bubble. Well, how could that plasma bubble be so perfectly spherical? So, we kind of put that to rest. When looking at these embossed images, we can clearly see that it's not a bubble. It's a solid object traveling through space, orbiting our sun. Really. And what amazes me, once again, months ago, many months ago, I caught the same type of photograph showing all of these larger bodies. And when I mean these bodies that I'm circling here, and I'll show you, there's some here, there's some here. They're all over the place. Folks, realistically, these smaller objects that I'm showing you, let me back up here. These smaller objects are like the size of the Earth. Some of them may be even bigger. So magnified, right in front of you. So let's just jump back. So we see the larger body here. And you could see there's one right there, one smaller one. So let's move on. So we magnify it. So we see one here, and one here, as I have circled. Interesting. So we back up, and we take a look at the spherical body right there. I mean, yeah, it's a little pixelized, but it's magnified like, 500 times. But even though it's slightly pixelized here, you could still see that is a round, spherical body in space next to this giant. And then you have one here, you have one there, you have one here, these two out there, possibly one here, and two right there. So let's move on. Let's take a look at these two. Actually, there's three. 1, 2, 3. Possibly a fourth, but it's not clear. So I've labeled these three. It's not like we're playing make-believe. They're there. They are there. They appear in all of the other photographs, but they weren't as clear as what we're looking at right now. Could these be, part of the system? That's very hard to say, because sometimes in the data that we get, we don't see them. We don't see these smaller bodies. Maybe they are there, but the resolution is not good enough. The light coming from the sun, the coronal mass ejections, the way that it's hitting the objects, maybe we don't see them. But every now and then, we are seeing them. So that kind of moves closer to the hypothesis that, yes, this isn't just one body in space. Maybe it's possibly a system. And that's been said quite a bit. The Planet X system. Is it possible for another type of planetary system to enter into our solar system? Of course it is. It's space. There are billions of stars, billions of rocky objects, billions of planets, billions of other stellar objects. So of course it is possible. Let's take a look at this object. Kind of shaped like a potato. Once again, if you watched my last video a few weeks ago, we were able to capture kind of an oddly shaped object. It seemed like it had a chunk taken out of the top of it. Well, this time around, right in the middle of this picture, we see this kind of potato-shaped, I don't know, it could be a rock. It could be an asteroid, but I doubt that it is because of the size of it. So, if that was an asteroid shaped like a potato that you're seeing on your screen now, that thing would be probably 1.5 to 2 times the size of the Earth. So therefore, I don't think that it would be classified as an asteroid. But it's freaking massive. And you still have these people out there that, maybe they watch my videos and, they come up with these crazy comments. Oh, that's fake. Come on, man. You got to do better than that. Every single day, every single tick of the clock that you look out into space, it's just absolutely amazing. The activity going on. This is just a very interesting subject. Maybe because some people don't have a clearer understanding, or maybe they haven't done their homework. Maybe they haven't followed this subject matter as long as I have. And then you make these discoveries. It is very interesting. It's very intriguing. This object here is even more intriguing because it is a massive object. At first I thought it was 2 objects very close together, but it looks to be one large, kind of potato-shaped rock of some kind. Could it be one of the moons? Could it be, another large, rocky type object that has, been caught up in the gravitational forces of this object? It's all a possibility. It's all a piece of science. I find it very interesting. I don't know about anybody else. Now, once again, to get past the space bubble or the plasma bubble theory, once again, we take a look at this photograph, and we're seeing the same large spherical body almost directly at the sun's equatorial region, the middle, where we always see it, and that is due to the way that it orbits the sun. This is where we're going to capture it, on both sides of the sun. Sometimes slightly a little higher, sometimes slightly a little lower. That all depends on when the camera systems on these spacecrafts that monitor the sun snap the picture. Because people ask that question also. So it's all based on timing, folks. If you've ever taken a photograph yourself and you're trying to capture something, guess what? The timing of when you snap that picture, well, that's going to delegate if you're going to capture what you wanted. Maybe you were too fast. Maybe you were too slow. Maybe you were just right. And you captured the picture perfectly. Well, that's what we're looking at right here, right now. So it's not a plasma bubble because it's perfectly spherical. Go outside, play with some bubbles, blow some bubbles. You tell me how many of those bubbles are perfectly spherical when you have other forces such as wind and the forces of blowing the bubble. How long does the bubble stay in perfect spherical formation? Not long. So those other forces will cause it to, have different shapes. But this object is perfectly spherical. And right up here, you can see the big potato rock, we'll just call it. It's right there. So are the other smaller bodies. You could see them. Let's move to the next photo. Same thing. You could see that weird shaped object right there. You could see the other smaller object that we looked at. Here they are. This black area here, because this is inverted, this would signify large portions of heat. And since it is situated that backside directly towards the sun, naturally you would see that. Now this is very interesting because that one little sphere that we saw there that I have circled, this is a zoomed in version of it, little pixelated, but this is a little weird because it looks like a black circle with a white circle around it. I'm completely confused of what that might be, what that is signifying to us. I don't know. I just thought I would point it out to you. Your guess is as good as mine. But I was examining each and every one of these other smaller bodies and seeing what I could find out. That's a sign of a good investigator, a good researcher. But I don't know exactly what that is really showing us. It's showing us something because it's there. But it was very, very interesting. It's almost like it's glowing. And then as we look at it again in a different format, now it's reversed. The center is light and around it is dark. So, is it some type of atmospherical situation going on? I doubt that because of the super close proximity to the sun. Any type of atmosphere would be dissolved within split seconds. It would not be able to survive. Is it glowing heat? That is a possibility. But I wanted to share these photographs with you because I just thought that they were just, absolutely amazing this time around at what we were able to capture. And again, I keep track of all of this, folks. Just because you don't get a video from me every single day, because I don't know, maybe sometimes I think you guys get bored with just, seeing the same thing day after day after day if I were to do daily videos. And there are so many current events going on that, I could speak to, and I probably will. I've been last couple of weeks, pretty busy, dealing with some things and taking care of Dr. Albers. And, she seems to be doing somewhat better on certain days, And I know as much as a lot of you would, like her to jump back on YouTube and, do more videos. I don't know if that's ever going to happen, but we'll see. She had a pretty good week this week, but just yesterday she started feeling that real severe fatigue, and then later on in the afternoon into the evening, she started undergoing that almost like a complete body pain. So, got to keep a close eye on her and help her out when needed. But once again, amazing photographs coming at you right here on Planet X News. And folks, do me a favor. Make sure that you guys are subscribed to this channel. Make sure you give it a thumbs up, because YouTube looks at all of that little criteria. Share the videos. Let other people see what you see. Let them experience all of this. Maybe they don't think it's an incredible thing, but I do. This, to me, is historic. This is historic data. Truly amazing. So give it a thumbs up, like that video. Make sure that your notifications and your subscriptions to this channel are in place. All right, folks? And listen, when it comes to this heat wave, if you are experiencing anything related to this heat wave, use your head. Use precaution. Okay? Prepare for it. Whatever you need to do. What I worry about is the power outages, the effects on our electrical grid. Because when the power goes out, you don't have air conditioning. You don't have any way to run a fan. So try to have a little plan, be safe out there, and make sure you all stay tuned to Planet X News. Be safe, folks. Take care. I'll see you soon.